Hello friends, welcome back to the bench. Today our patient is a 50-inch TV, and actually it won't fit on the actual bench, but I have a little table over here on which I have it. Now, what is wrong with it? It doesn't work, okay? How to fix not working TV, especially TV this big? Well, first of all, you have to have enough room. In my previous shop, I couldn't tackle a job like this because I only had this bench to work with. Now I have my additional bench for big items, so let's tackle it. What usually goes wrong? Well, most common fault is when you drop it and the screen just breaks. It starts flickering, or it produces just white signal, or some just interference, nothing really meaningful on the screen. That would be fault number one, and you know, in that case it's not really worth a repair, because as long as the screen is working, it's worth a repair. You can go as far as even replace the entire motherboard. You can buy those. To replace the screen, that's the majority, unfortunately that's the majority of the cost of this device. So it's not really viable to repair these when the screen is damaged. This one has a probably working screen. So first thing that we're gonna do is we're gonna take a multimeter in resistance mode and check the resistance of the plug. So two things we can see here. If it's shorted, well, it shouldn't be. It should either be what we see now, some mega ohms, and the resistance keeps dropping because the capacitors are charging, or we just see OL. If we see OL, probably our fuse is open. And the fuse is open probably because there is a short, probably the transistor. So this is not our issue. So once we confirm that, let's plug it in and see what it does. Now, as I plug it in, there's a little spark that tells me that the capacitors have charged. And there's a single button on this one, which doesn't exist. It has been removed. We see the red light blink, the TV turned on for a second, and two blinks, and again red, went down, so it's starting to boot. The screen turned on for a second, two beeps, two blinks, and it dies. So what does that tell us? That means the TV is trying to boot. So that's good. That is a good news. I actually started this assembly in a way where I unclip this and the screen is just coming off. But I don't think that was a good idea, because now I see a little discoloration over here. So that's probably because the air got in there, and I probably should have been using gloves, because you don't want to put the fingerprints on the other side over there. So there might be some display issues either way after, even if we fix the issue with the power. But now, what is my suspicion? If it does that, so it tries to boot, because normally your power supply will most likely be at fault in those TVs, because that's the first thing that usually will break. We have at least 3 voltages on the power supply. One will be standby voltage. That's what powers our electronics that tell the computer to turn on. It was partially covered. So our standby voltage supplies everything that needs to be powered on to tell the device to turn on. Second voltage will be slightly higher, roughly 5 volts, and that will be supplying are electronics that require a little more power than the standby can deliver. So the power supply needs to turn on for that voltage to be present. And finally, our third voltage, there might be more, but at least these three are required. Our last voltage is a high voltage. By high voltage, I don't mean actual high voltage, I mean 24, maybe 48, probably no more than 60 volts. And now that voltage is generated for the LEDs, and this is the part that consumes the most power out of this entire device, because it needs to light up the screen. There's a lot of LEDs and they consume a lot of current. So to reduce that current, we use higher voltage. That's why that voltage is so much higher. Now, since trying to open it from this side didn't work, and probably I shouldn't have even tried doing that, because now we're gonna have to figure out how to fix what I broke. But we'll see if that even is going to be a problem, because first we need to figure out what's wrong, that it doesn't want to boot. My suspicion is that the capacitors are at fault. Now, capacitors will be the first thing that will break in any kind of device, because they go dry. They work hard and they are designed to work for 10,000, 20,000, 50,000 hours, and that's it. That doesn't mean that it's actually 50,000 hours or 20,000 hours, but you know, the capacitors come with a deadline, with expiration date, not like transistors or resistors, more passive components. Now, it should withstand, let's see, it should be able to withstand this. Okay, and these are huge mounting screws, and probably after we take off those mounting screws, we can lift the back and have access to the board. First access we want is the power supply, and we want to measure the ESR and capacitance on the capacitors. If either ESR is very high or the capacitance is very low, that would explain why the TV is not turning on. Because most likely what is happening, it prompts the power supply to boot, to start delivering voltage. The voltage is delivered, the LEDs light up, but as soon as the load is connected, the voltage fluctuates or drops, and the power supply detects that as a fault and shuts down. And then again and again. That's why we have this boot loop. If that is the case, we can fix this. If something else is wrong, not so much. These are some serious screws that are holding the mount. This is our board. So if the issue is here, we can fix it. So there's our fuse, which is good. Oh, come on, where's the focus? But the fuse is good. So let's put it on the bench, get some better visual. These are our main transistors. Look at this beautiful coil. Our main transformer here, I assume. So, the caps we're interested in are these and this one. Now they are not bulged. That would be the best case scenario. If they were bulged, that would immediately tell us that the caps are at fault here. But they are not, so let's do some measurements. These are 470 mic. So my fluke should be able to measure that. I didn't check for shorts actually. Okay, the fluke says nothing. Let's grab a different device. Let's try our trusted Chinese fluke wannabe meter. Never fails. We have 1.4. So 1.4. If these all three are, well, they are. Yeah, they're all three in parallel. So they're roughly 500 times 3, that's 1500, so that checks out. So our output capacitance is okay. So really no need to measure the ESR. I don't think the caps are at fault here. Neither the visual or the measurements suggest that. 32 mics on this one, and it should be, oh, it should be 8.2 at 400 volts. That's a big one. So we have higher capacitance on this one, but again, is it in parallel with some other cap, which messes up our measurements? Yes. Yep. It's in parallel with this one, which is also 8.2. There's one more here that is missing, not installed. But again, that's still, because we got 30 mics. That's too much. So let's check the ESR. If we can find an ESR meter. See, I'm still kind of unpacking, so I don't have everything ready at hand yet, but we're getting there. So this will be an ESR on all of those caps. Let's see what we get here. Oh. Okay, we are getting very high ESR. That would explain why the capacitance is high. Higher than it's supposed to be. And now, the question is, what is that cap for? Because don't fall into a trap where you identify a cap that has higher ESR or higher or lower capacitance or higher capacitance, and you just blindly replace it with something similar, not exactly the same. In power supplies, some capacitors are calculated, their capacitance is calculated to delay the signal, usually in the PG, on the PG circuit. There's a capacitor that decides that decides when PG goes high. and it needs to be delayed in some power supplies, and that's what is achieved by the presence of that capacitor. So don't assume that any cap that is showing up different is going to be at fault, but in this case this is the cap. Let's take a look at it, and actually let's get a better view. This is our cap. So the positive is here. We have a diode over here. Looks like regular diodes, reverse polarity, because it probably controls the coil. We have another small cap here, and that goes to our connector, that goes to the logic. And we have another cap here, and another diode, and another cap here, and this one is missing. So on this line we're getting higher capacitance, and our ESR is over 1 ohm, so very high. So now let's try this. What's the tip I have here? This one, that's good. Okay, the cap is gone. Now let's do another measurement of capacitance on this rail. Now we have 24. And let's check the ESR now. It's even higher. 1.5. So let's continue. Let's get rid of this guy. Okay, the more caps I remove, the higher. Now we're at 2 ohms. The higher ESR I get, the more caps I remove. So let's check the ESR of the cap itself. These are high voltage, 400 volts. The ESR is not that important on these. It's on those that have high capacitance. Yeah, 3-4 ohms. So very high, but that's to be expected. High voltage capacitors will have higher ESR than low voltage capacitors. Let's check their capacitance, but I don't think we're going in the right direction. I don't think this will be a cap issue. 9.7, yeah, it should be 8.2. So slightly higher, but not hugely. Yeah, 8.2 on this one, and it should be 8.2. So this one's better, this one's worse. We probably I'll probably replace them anyways, but I don't think that will be our issue. Let's check capacitance on it again after 2 caps are removed. 16 mics. So what else is giving us that capacitance? This one. What does it say? That is a cap, but I guess this one is giving us that 16 mics. I would think, and that is the high voltage side. Well, actually this is low voltage side, but the caps are 400 volts, so this is relatively high voltage here. And this is cold side. on hot side, I don't think we need to worry about anything. Let's check the measurement on the smoothing cap. Not that it matters too much, but let's check it. We have 4 volts DC on it. 4 volts, 4 volts, we can just short it like this. 4 volts is nothing. And let's check the capacitance of it. 98 should be 100, so this is fine. Smoothing caps are very rarely at fault, but it happens. It definitely happens. Okay, I didn't check for shorts because the board is booting, right? We have a first boot, and you know, so if there was a short, we probably wouldn't get that far. What are these? These are probably diodes. Yeah, that's the diodes. So let's check the diodes, but if that was the issue, we would see it differently. Yeah, this is fine. Well, let's just blindly check few components here, like this big diodes, but that's not gonna tell us much. Now the hot side is okay. This is the hot side. The cold side here. These caps. Let's see these caps over here. First, let's check. Is there? Oh well, there is. Let's check the. But I think I already checked these, right? 16 mics. Why is it so low? Oh yeah, because these are also 400 volts, 8.2. Yeah, these are all good. So, no, that's not dry caps. So, in that case, what else can we do? Let's do some visual inspection of maybe the motherboard. There's not much on the motherboard. So the one last thing that we can check is this little buddy over here. Let's see, how do we... There you go. Okay. I gotta replace those caps before I start testing again. But this is what I expected at first. But the issue is gonna be somewhere here. But before I even disassemble it, I had good access here, and I concluded that it should be fine. But now looking at it, I think I may know what the problem is. How do we disassemble this? So this is the on button, that's where our LEDs are and everything. This is also our IR reader. And if it's always pressed, that would explain the boot loop, right? No, and you're not seeing anything. Sorry about that. Okay, this is our button, right? We have IR LEDs over here, or diodes, the photo transistor and the diode to communicate with the remote. And this is some kind of radio, so this is Wi-Fi, Bluetooth transceiver. Yeah. So basically this controls our TV. So if there's something wrong with this, that would explain that the TV is going into a boot loop. If the button is always pressed, for say the button's always pressed, this one, then it just keeps turning on, and then the button is shorted, so it turns off, and then it turns on again and off again. But we see that there is no short, right? So this is fine. In the broad sense of the word fine. Okay, now the second thing I did, I checked this, right? Because if this is a cap, right, and you see that this has been hit way too many times, enough to break this button. So what happens if you press on the cap? It goes short. And this is dead short. No point. Yeah, this is dead short. But is it a cap? I don't think it is, because it is connected to this, right? But not to this. Now the caps are very commonly used along with buttons, but they are in parallel, not in series, and this one is in series, so I don't think this is a capacitor. I think that is something else, something that should be short, especially since it's connected to the button, right? Now let's see, this one looks the same. Yeah, and it's also that short. So I don't think these are caps, because that would be a nice nice repair if this was a cap and it was shorted, because it fits. It's in the place where we see the damage, the physical damage. But that's not it. That's not gonna solve our problem. And what else can we see here? Maybe these are just LEDs, and this is probably for reading the IR. But the remotes for these TVs use radio anyways. They don't use infrared. Antenna, yeah, nothing more here. So now, to fix this TV. Unfortunately, it was not an easy repair. Usually when you have a cap, you find a shorted cap, you replace it, it works. You find a high ESR or low capacitance on the caps on the power supply, replace them, and it works. Physical damage, right? Some ripped cable, some ripped connector, that kind of stuff. Again, easy peasy. But here we have a fault that would require us to connect a diagnostic device to this device for the TV to just kind of tell us what is wrong. At this point, that's our well, that would be the best way. But obviously we don't have that, and we're never going to have that. So next step is to start eliminating stuff. I really don't think that the power supply is at fault. I do think that this might be at fault, and there might be something wrong on the motherboard. But my first step will be to find the replacement for this button. It's just one board. Let's hope it's not paired to the rest of the device and it won't work if you replace it. Let's hope that's not an issue. And we'll replace this. There could actually be another issue that I didn't think of that would be related to power supply. Actually not even. So because it turns off as soon as the LEDs turn on. That could be a coincidence, but if one of those LEDs is having an issue, meaning it consumes too much power, that would explain why it turns off, because that's something that the board will definitely detect, how much current is being consumed, and if it's too much, it'll go into emergency shutdown. But that is pretty much all we can do here without the replacement. So unfortunately, this was not an easy repair, but we have a way going forward. I'm gonna scout the eBay, look for this particular board. If it's like 10-20 bucks, I'll definitely get it. If it's like 200 bucks, then sorry, this TV is going to the trash. Actually, that's just the big parts. The board and the power supply and the speakers I will keep for parts. Well, too bad we couldn't fix this one, but I'll keep you guys posted once I replace the button, and perhaps that will resolve the issue. Alrighty, thank you guys very much for watching. I hope you like my new shop. I just moved this week, last weekend, so I'm still kinda trying to get organized, and there's a lot of work at work and outside work and a lot of stuff to deal with. So I'm slightly busy, but never complain about being too busy, because the other side of that is even worse. Alright, thanks again guys, and I shall see you in the next one.